What up guys, John here. Pretty exciting time for me. As you can hear, I'm machining titanium right now for pretty much the first time, except for some light engraving work. But I'm doing some pretty serious, for me, machining of titanium, so let's check it out. So this is so not the ideal setup, by the way, but let me disclaimer that. But here's a big piece. It should not be this long. This is probably vibrating like crazy. I can feel it actually with my fingers. But so I've got a little 1/8" end mill in there. Super slow. It's running at about 3,000 RPM at 4 inches per minute. 4? I thought it was supposed to be 2. Anyway, 4 inches per minute. Pretty slow. I bet you 4 is the finish pass. And see, right now it's plunging down at 0.6, which is uber slow. But you can hear it going away. So 1/8" end mill. My step down is about a 1/16 of an inch. Obviously holding with the drill chuck is a terrible idea, but that's all I have for right now. I'll be doing ER collets eventually, but it sounds fine. I mean, it sounds very manageable. You know, it's not straining itself or anything. Anyway, so what I'm machining is a Christmas present for my 5-year-old nephew. It's a Superman pendant, basically, a Superman necklace out of titanium. Of course, why not? So I'll show that once I get some more progress here. Ah, darn it. Broke the end mill. And I probably work hard in that little hole right there. I heard it snap off too. I can't really see it, but pretty sure the problem here is that I was feeding straight down, even at 0.6 inches per minute, which is uber slow. It's feeding straight down when that's kind of the worst way to feed an end mill. It's a bad habit of mine. What you should be doing is feeding either in a clockwise, or whichever direction, circle, or ramping down at an angle. I gotta start doing that from now on. Crap. Brand new end mill too. Yay! However, you can see the S of the Superman showing out pretty good there. Surface finish, wall finish looks awesome. Depth looks fine. I went all the way through to the aluminum. Dang, that looks great for what worked. It's just this little hole in the corner that didn't work. Crap. So I'm gonna recode it, I guess. Add some either angle ramping or circular interpolation, they call it. And try it again in a different location, I guess. Man, that little corner was perfect too. Yeah, because I can't keep going like this and expecting it to work. So, but yeah, it broke. I could hear it. It broke right when it was going straight down, not turning or you know, going to the side or anything like that. So, poo. So there you can see my failed attempt. That silver hole right there. I tried to drill through it with a drill bit and burned up the drill bit too. Yay! So either there's carbide stuck in there or it work hardened like crazy. But looks pretty cool. I mean, what worked really well. So I've recoded it. I have moved the plate forward. So I'm going to be machining this section right now. And I've recoded it. Some of them are helical interpolation. They go down in circles at a 45-degree angle. And then others are 45-degree straight angles, like angled lines. So I'll see the difference and see what works. You can't even tell. It's doing helical interpolation, but you can't even see it moving. Yeah, I'm feeling the ball screws. Well, here you go. So they are moving in a circle just very, very, very slowly, so you can't even see the table moving. Hopefully it fixes my problem. Also, my theory is because now it's going down at a 45-degree angle, it's taking twice as long to get down. So it's moving a lot slower as well. So one thing I'm noticing, as I'm watching that plunge down helically, is that as it's going down, it's collecting chips at the base of the end mill. You know, like if you've ever seen a drill bit plunge down, all the chips come up and then they stay on the shaft and they spin around and around. This is happening on my end mill right now. So chips are attaching to the halfway up the shank, and they're spinning around and around, and they're blowing my coolant away. So I don't think coolant is really getting at that at the cutting edge, and that might have been one of the reasons why the end mill broke in the first place. But seems to be going pretty good right now. I'm not quite as far as I was where it broke last time, so. But it looks good, it sounds good, it's producing chips, so that's good. This part is where it broke last time. So we're going down, down, you can see the ball screws moving slowly. Going down, almost all the way to the first cut. Doing the first cut. See, if you look really close, you can see there's chips flying around the end mill. And coolant is not quite getting there. It's just being blown away. That sucks. Higher pressure coolant, I guess, would help with that, but an air blast would really help with that. Well, looks like we're doing good so far. So I'm doing the profile pass right now around the outside, and I'm leaving little tabs. So you can watch it lift up right about now. Up. Back down. So at full depth it's, you know, going all the way through, and then when it lifts up it just leaves a little bit of a tab. That's a lot of metal shavings for such a small little part. How do we look? Awesome! So I left little tabs. I'm going to go in there and clean it up with a 1/16 inch end mill, half the size of what we just did, and it's going to get into all the little corners and recesses and make the S stand out even more. Basically enlarge the holes just a little bit into places where the 1/8 inch end mill doesn't fit. And hopefully my little tabs that I left are strong enough. They should be. They're holding it on all three sides. The three long edges of the emblem. So we'll try that now. So taking a really close look at my end mill. This was brand new before doing this one job. Remember, we broke the other side. So this one piece that worked, this end mill was brand new, and looking at it really close with a little kind of a magnifying thing. I got this out of a scanner. But if I hold this up to my eye, it's like a little loop. I can tell that every one of the four corners is chipped, and the face, the flat edges, sharp edges there, also have some pretty good gouges out of them. So titanium's not so easy. It's hard on tools, and I'm babying the settings here, just babying them. But boy, I'm sure having a holder that's better than my freaking drill chuck will keep this thing more concentric, and possibly reduce that, but that's sort of speculation at this point. I'm sure it can't hurt though. It's going to be a lot better with a proper holder. Finally, holy cow. An hour and 35 minutes with that 1/16 inch tool. It took forever. Stupid solid cam thought it would be hilarious to machine every pocket 3 times. Not even joking. However, super hotness. Yeah, that'll do. Damn. So last thing is right in the middle here, I'm going to engrave Zachary. Using a 1/16 ball mill. So let me change tools and we'll do that. Nope. Wrong piece of code. I'm an idiot. Alrighty, now that I have the correct piece of code, we can hit go. So, notice how it raises up so high in between each cut. That's a setting you can set in the program, and it's really tricky getting that setting right because it doesn't need to go very high up. Like for this engraving, it can just go up 10th thou or whatever. But for cutting other parts, you need to go up high enough to clear all your bolts and fixtures and everything, and make sure that it doesn't crash your tool into all kinds of stuff. So, like for this part, I just forgot to keep it really low. So it's raising up 0.4 of an inch, almost half an inch. So whatever, it just takes a little bit more time. Not a big deal, but just about done. I think I got one more letter. All done. Can't tell if that ruined the awesomeness of the S or not. Oh well. He's 5. My thinking is that a 5-year-old would think it's 10 times cooler with his name on it. So why not? So you can see right in front of my fingers a little tab. There's one right in front there, and then there's one up here. The center of each of the 3 lines. So we're done now. We'll pull it out and check it out. There we go. You can see the 3 tabs. Maybe this will help. No. There. So you can see my 3 tabs. I programmed them to be about 20 thousandths of an inch thick, and they look like they're about that, so that's awesome. And here's from the back side. Sweet. So now I just gotta break it out. Don't know if that's going to be easy or hard. But edge finish looks fine. Not fantastic, but acceptable. For my for being cut from a drill chuck. Let's see if we can get a close up here. That's as good as you're going to get. And I wanted to say real quick, this little bugger took 2 hours and 14 minutes of actual machine run time, which is a bit redonkulous if you ask me. About 25-30 minutes of that was roughing it out with an 1/8 inch endmill and profiling it, so doing most of the work. I'm fine with 25-30 minutes. And then another hour and a half on top of that was cleaning it up with a 1/16 inch endmill. Doing most of the cleanup 3 times. Stupid solid cam. Sort of my mistake. I used a setting I've never used before. But it does look awesome. So it broke out really easily. Right on either side of that lip, there are 2 little gouges. Now what I did for the last profile pass at full depth is I went around and then I went up a little bit, over, down a little bit, and that's what left that little pip. And going up and down caused those 2 vertical lines. I figured it would do that. So I'm not surprised, not concerned either. But it's good to know that, you know, for high quality, nice looking parts, that's not really a trick that I want to do. Because it looks stupid. That's 400 grit. You saw how long it took me, not very. A little bit more, I can still see some vertical scratches. I'm trying to get all the grain one way. And then I'll step it up to 600 and then flip it 90 degrees and do it the other way. It's turning out quite good so far. There's some deep scratches, so I took 320 grit and then 400 and then 600. And looks pretty awesome. Between the Scotch-Brite and the sandpaper, the hand sanding I just did, it doesn't really need to be tumbled. But I do want to kind of get into all the little corners and deburr all of those because some of them are pretty sharp still. And remember, we're dealing with a 5-year-old who has a 2.5-year-old younger brother with very tiny fingers. And my 2-year-old little girl with very tiny fingers. So, time to tumble. And if I don't get a chance, this is what he told me, and I quote. He said, I saw these Superman necklaces. Do you think you could make one and make it green like Green Lantern? So you want a Superman necklace, pendant, green like the Green Lantern. Yeah, I've never seen one like that. Okay, sure, I can do that. So I'll probably anodize it green, 95 volts, and awesome. Here it is after tumbling for almost 8 hours in ceramic media. Not a huge noticeable difference, but every inside corner is sort of lightly rounded off, and no more sharp edges anymore. These divots bug me, but that's okay. As I said, that's from where the tool goes up and then down. But I think someone's gonna love it. Now to anodize. So right now I'm playing with my anodizing setup a little bit. So I'm going to try to make this thing colorful. Hopefully, I don't know, it looks pretty dark in the video. So what I'm going to do is I'm going to turn it to 50, 60 volts. It's yellow. That's 70. And then I'm going to flip the switch and we should see it go through all kinds of different color ranges. And go. There's bronze, blue, getting up to yellowish. It's a big part, so it's taking its time. I'm gonna knock the bubbles off. It's 65 volts. Yeah, that's yellow, alright. Dark yellow. I'm gonna crank it up to 90 volts, see if I can get a green out of it. And then I want to strip it off using multi-etch heated, which is something I'm trying for the first time right now. It's 92. Anyway, that's 94.4. So I'm going to pull that out right now. It's pretty awesome. So in here I have a big stainless steel pot on a burner. Water temperature is 147, and I've got my my multi-etch in there as well, and that's at 138. I'm shooting for 140, so that's good. You can see it's kind of a double boiler setup here. And this is supposed to strip this green color off in seconds. And my part doesn't fit. Haha, idiot. Maybe I'll transfer to a bigger container. Using heated multi-etch, I was able to get this pretty awesome green at 90, almost 91 volts, except it discolored in a few places. So let's pull it out and take a closer look. There we have it, the finished part. As you can see, the discoloration on the upper left corners that I was talking about, I can only attribute that to the multi-etch, or the part was sort of greasy before. Because I didn't do a fantastic job of cleaning it off before putting it in. So a proper scrub with soap water or something might have alleviated that. It might still if I want to go back and strip it again and do it again, but I think we're going to have to call it good there. Let's see what the back side is. Yeah, again, same discoloration. What are you going to do? I'll just say it makes it look cooler. So, titanium Superman Christmas present, and let me show you how I'm gonna hang it. Simple rope, loop knot right there, the drawstring, and a double figure eight, and I'll clean up the ends and adjust the length to suit him. But there's a necklace for a 5-year-old. Overkill? I think so. Worth it? I think so. Probably got at least 5 hours into this piece. But it was worth it because I got to play with titanium. And this is the first thing I've ever machined in titanium. And all things considered, hell yeah. Thanks for watching, guys. Take care. Bye.